Welcome to part 3 of our tutorial series on using the environment editor. In this section, I'll be focusing on getting you up to speed on our real-time global illumination system, which we call SVOGI, or Sparse Voxel Octree Global Illumination. Sparse voxels. It's also common to refer to it simply as GI, or Global Illumination. I'll also show you the differences you'll see between using environment probes and SVOGI to add ambient light to your levels, how to optimize the key parameters, and debug what's happening under the hood. I'll be using CRYENGINE 5.6.5, so you may see some differences if you're using an older version of the engine, or newer if you're one of those magical time travelers from the future. This tutorial assumes that you're familiar with the sandbox and know at least as much about the environment editor as you can learn by watching the first 2 tutorials in this series, which you'll find right here. So what does SVOGI do, and why should you care? Well, it changes this to this. Now what you're seeing when I enable SVOGI, which is what I'm doing, is light behaving much closer to the way it does in the real world. And it does it in real time, which is cool. It accomplishes that by creating indirect ambient light in 2 ways. By providing ambient diffuse light, which is, for example, what you get from light trapped in the sky, on the sunny side of planet Earth anyway, and by bouncing direct light from the sun or light components. And that'll give you those nice little glows like you see here as light bounces off of surfaces, picks up the color of the materials, and kicks that reflected light onto other surfaces. You'll find the SVOGI settings in your current environment preset under Constants, broken into 2 sections, Total Illumination and Total Illumination Advanced. As you can see, there are quite a few settings here, and most of them probably don't seem very self-explanatory unless you're a rendering engineer. But the good news is that even though the sandbox exposes a lot of settings to you, in the vast majority of use cases, your best bet is to leave most of these settings at the default values. So I'm not here to turn you into a rendering engineer. Instead, I'm going to show you a very manageable number of settings that really matter. Although the technology behind this little checkbox is anything but simple, it's not hard to use once you understand what some of these settings do. Now, personally, I am a guy who likes to understand what every little switch and button does and why and what the theory is, but what I've learned from the people who've been using this tool for years is that it's not worth spending 90% of your time fussing over settings that will only affect the final result 0.001%. So I'm going to begin by creating a new environment preset so you know I don't have any tricks up my sleeve, and I recommend that you do the same so you can follow along and get the same results. It's also helpful to have a level that has some meshes with a variety of materials and some vegetation. I'm just using assets that you'll find in the free Game SDK sample project. I just dragged some of the object, material, and texture pack files from the Game SDK project into my assets folder for a blank project. I'm not actually using the Game SDK project. Next, I'm going to follow the basic steps that I covered in the previous tutorials when I first create a new environment preset. I'm going to ignore the curve editor because I'm not worried about dynamic time of day. I'm going to unlink the sun from time of day. I'm going to change its position in the sky so I get some better shadows. I'm going to desaturate my HDR so it doesn't add yellow to my scene. And I'm going to change the default HDR eye adaptation mode to be compatible with CRYENGINE 5 by typing R_HDR eye adaptation mode 1 in the console. I'm also going to enable volumetric fog by typing E_volumetric fog 1 in the console tool. As I said before, any CVARs that you want to be different from the defaults, you should add to your autoexec.cfg file here, or your .cryproject file. Now that I had the basic settings out of the way, now we can work on the creative stuff. I'm going to lower my sun intensity to 40,000 lux, which is much more realistic than the crazy default value. By the way, that's a leftover from back when we used a different unit of measurement. Now I'm going to go for a kind of a magic hour look, so I'm going to warm up the color of the sun a bit. And lastly, I'm going to go for a kind of a dramatic low sunlight and dark clouds look by enabling volumetric clouds in the console. Finally, I'm going to press Ctrl+S to save my environment preset. Now just a reminder that you have to save environment presets by pressing Ctrl+S in the environment editor, and that's separate from saving your level when your perspective viewport is active. In other words, saving the level doesn't save the environment preset. Now we also need to assign our new environment preset to the level. You'll find this listed in your level settings under environment presets. click the drop-down menu next to Presets, remove all to clear the default, and then what I like to do is just drag my preset from the Environment Editor's Asset Browser into the Perspective viewport. Save your level. Next, I'm going to add just one global environment probe, and I'm going to set its box size to 10,000 meters in each direction. Kinda big. Give it a sensible name, and then click on the Generate button and wait a few seconds for it to generate the cube maps. Good time to save your level. So at the moment, my SVOGI is still disabled, and if for some reason you wanted to not use SVOGI, you could add ambient light to your level by adjusting the contribution that your environment probes make to the ambient light by tweaking this diffuse multiplier value. Now this is in addition to the fact that cube maps are also used to generate specular reflections, which we absolutely need them to do. Now you could build your entire level using lots of environment probes and generate all of your ambient light that way. And it looks okay. Certainly makes a big difference. And it gets rid of the pure black shadows. But now let's compare that to how SVOGI produces ambient light. I'm going to enable SVOGI just using the default values. And immediately you're going to see a pretty dramatic difference. If you start with no environment probe and switch SVOGI on, the difference will be even more dramatic because there is simply no ambient light coming from the environment probe. So now that we've enabled it, let's adjust the most important settings to fine-tune it. First of all, the global illumination system is unusual in that it lets you explore features that are still in the experimental stages. So the integration mode here is at the heart of that. If you let your mouse hover over this, you'll see that there are actually 3 modes, one of which is labeled experimental, and one that's labeled very experimental. Now play with those all you like, but today I'm only going to work with mode 0, because frankly that's the only one I'd consider valid for a shippable game. So if we go back into the hangar, we can see the 2 main components of global illumination in play, which are bounce light, whose intensity is controlled by this injection multiplier value, and diffuse light, which is controlled by this Sky Color multiplier. Now to help you visualize exactly what's happening, I'm going to enable one of the most useful GI debugging tools. Here in the console, we'll type R for renderer, in case you hadn't figured that out already, _ show render target. Now you probably remember with console variables, if you put a question mark after this, you'll see all of the possible parameters. And in this case, there's a really long list. The one we're interested in is SVO for SVOGI _ FIN, final, finesse, I don't know. Now what you're seeing in this overlay is just the output of the GI system in real time. So I'm going to turn both my injection multiplier and my Sky Color multiplier down to 0. And you'll see that the debug view has gone almost, but not quite black. Now at this point, SVOGI is contributing large-scale ambient occlusion, but pretty much nothing else. Now it probably looks like our debug window is just blank and empty and sad at this point, but let me just ask you once again to notice that it's not black. It's actually indicating a value. And what that not quite black value represents is really one of the unsung heroes of the whole GI system. And that's this guy right here, Diffuse Bias. Since Diffuse Bias probably isn't really very self-explanatory, I'll tell you its secret purpose, which is to bring light into the darkness. Literally. And what I mean is that this controls how dark the darkest areas of your level are. You can think of it as something like minimum brightness. To show you more clearly what Diffuse Bias is doing, I'm going to kill most of the light sources in this scene. I'm going to set my sun intensity to 0, Skylight sun intensity to black to kill the sky. My bounce light and my Sky Color multiplier are already set to 0, so they're not doing anything. And I'm going to disable my environment probes. I'm going to leave the Humvee lights on and my little fire burning there in the background so we at least know where we are. And now the only light we have left to see other than the Humvee and fire is provided by Diffuse Bias. It's literally all that stands between us and complete darkness. And if I do set it to 0, you'll see what we're left with. Pitch black. So if complete darkness is your goal, congratulations, you're done with Diffuse Bias. But in most cases, you'll want to use this to make sure that your players are never accidentally plunged into complete darkness, since it's kind of tough to navigate a level when you can't see anything. Also, if naturalism is your goal, which obviously isn't always the case in game design, it's just not realistic for human beings to see absolutely nothing, unless we're living in a cave, or a box, or a refrigerator, hopefully with a vent. So if I raise this diffuse bias back up to a higher value, you'll see why it's so powerful and kind of dangerous, because it's definitely not a realistic source of illumination. In fact, I'd suggest that you don't think of it as a light source, but kind of as a tool to carefully modulate the darkest areas of your level. Now, it turns out this was exactly the challenge we had in our own Hunt Showdown, where the goal is to force players to dip around in dark basements and scare the hell out of them with all sorts of horrible monsters, but still make sure that they can see well enough to navigate long enough to die. But we at least gave you enough light to see what killed you. We also used strategically placed lanterns and projector lights to fake sunlight, but you didn't know that, poking through the walls of the buildings, which in Hunt Showdown are almost all conveniently rotten and full of holes anyway. Then we tweaked this diffuse bias value to modulate our shadow so it was dark and moody, but never pitch black, even though it probably feels that way. And that's exactly what I recommend doing in your own game after you get all of your other lighting and your other GI parameters set up. So yes, we're kind of going in reverse order and looking at this diffuse bias first, but hang on, we'll get there. In Hunt Showdown, a diffuse bias value of 0.013 helped us keep those basements nice and dark and spooky, but still navigable. Obviously, the mood and lighting style of your game may be different. So I can show you another way to use diffuse bias, and it'll also be easier to see in the debug window. If you hover the mouse over this parameter, it'll explain that a negative diffuse bias will allow short-range ambient occlusion to actually modulate the diffuse bias dynamically. So let's give it a try. I'm just going to use a small negative value, and in addition to seeing a constant ambient light level in the scene, you'll also notice in the debug window it shows up on your actual meshes and terrain. So that's actually showing you close-range ambient occlusion using the diffuse bias to modulate the minimum light levels. If all of that sounds really complicated, again, it's just like minimum brightness in your scene. Now again, this is just relevant for ambient occlusion about 2 to 3 meters from the camera. If I move up, up, and away like a beautiful balloon, you'll see the diffuse bias disappear completely. Bye-bye. So I've prepared some direct A/B comparisons so you can see the difference between a negative and a positive diffuse bias. In this night scene, I've lowered my injection multiplier a bit to 0.3, and for the moment, I've set the diffuse bias to 0 so we can see our scene at its darkest. Now let's compare how it looks with just a tiny bit of diffuse bias, negative 0.03. And then compare that to a positive 0.03. There's not a huge difference at these values, at least not yet. Now let's compare that to a value of negative 0.13. Now that may be a small numerical difference, but there's a big difference in how it looks. And finally, compare that to a positive 0.13. If you look back at these comparisons, you'll notice a bigger difference between the positive and negative 0.13 values than between the positive and negative 0.03 values. Here's a look at the same scene from a reverse angle using the daylight settings we started with the sun, the skylight, and the environment probes back where they were. Again, we'll start with a 0 diffuse bias. Now compare that to a diffuse bias of negative 0.2 and to a positive 0.2. So just a reminder that it's useful sometimes to use this debugger and isolate each component of the GI so you can see exactly what's happening, like in this case, turning off bounce light and skylight and just looking at what your diffuse bias is doing. But needless to say, you should eventually turn on all of your settings and do your fine-tuning with the final image. So that's how diffuse bias works. I'm sure that you've already realized that very small amounts of diffuse bias have a dramatic effect, so be gentle with it. If you lose all sense of restraint and crank this bad boy up like this, none of your lighting artist friends will ever buy you another ice cream cone, ever again.
No ice cream? No chocolate sauce?
Remember that I said that there are two main components to the GI system, bounce light and skylight. I'm not including diffuse bias because it's really not a light source. So let's look at these two components in depth. I'm going to disable my skylight by leaving my sky color multiplier at 0 and bring up my injection multiplier to isolate the bounce light. In the debugger, you'll see not just the brightness, but also the colors of the light sources being bounced around, warm sunlight, red taillights, warm headlights, in this case. For real-time performance, I don't recommend that you crank up your injection multiplier too high. 1 is typically a good reference point or a good starting point. But when it comes to bounce light, how far the light rays are traced will also make a huge difference. And that's set by our friend here, cone max length. I'm temporarily going to amplify the intensity of the bounce so it's easy to see, and set the cone max length to a very short distance, like 3 meters. In fact, I think the minimum is 2. With such a short bounce, you'll see that the GI is kicking some light from the floor up onto the walls, and it's giving a subtle glow on the side of the Humvee, which is actually easier to see in the debug window than in the scene. And it's doing absolutely nothing on the dark ceiling. Now, subtle is definitely not a bad thing. Just compare how that bounce looks if I turn it back to 0. Huge difference actually, but it doesn't draw attention to itself when it's on. If I change the cone length to 5 meters, I'll get more of a kick on the side of the Humvee, but still nothing on the ceiling. Once I get up to about 12 meters in my case, then we start to see a dramatic effect even up on the ceiling. And now we can adjust our injection multiplier back down to something more subtle and fine-tune until you're happy. Now just a reminder, this is global illumination, so this is a global setting like everything else here, not something you can tweak for different spaces. And it's super important to be aware of the performance cost. The shorter the bounce, the faster it works. Unfortunately, the longer your cone max length is, the better your lighting usually looks, most noticeably in those telltale gradients that characterize believable transitions in and out of shaded areas, like you'll see here in Hunt. But at the maximum length, I can guarantee you that performance is definitely not going to be viable. One last thing about bounce light. It wouldn't be very useful if it wasn't affected by the color of the materials that the light is bouncing off of. So I'm going to reveal a series of simple boxes with different colored materials that I've put here in the exact same location to reflect sun onto my Humvee. And as I show each one of them, you can see that indeed the color of the bounce light changes.
Bounce-alicious, baby.
Next, SVOGI provides ambient light, so we finally have light from the sky just like the real world. Yay! You control this largely through these 2 parameters. Sky Color Multiplier sets the brightness of the SVOGI ambient light. Now there's absolutely nothing to stop you from going completely bonkers with this, except, good taste and common sense. And under that, we have something very, very important and very, very strange called Use TOD Time of Day Sky Color. Now, what this does is really simple. It sets how much of the sky color is used to saturate SVOGI's ambient light. And when I saw this, I thought, great, what could be easier? SVOGI finally makes the sky emit diffuse light, just like the real sky. Fantabulous! So this Use Time of Day Sky Color is just like a little bonus slider that lets you tweak the saturation of the light the sky emits without having to change the actual color of the sky. That's cool. Yeah. Anyway, so if I have Skylight, that means if I'm making
Space Dragons Invade Mars. Again.
And I need a nice juicy red Martian sky, being the environment expert that I am, I reach over here and I adjust my Rayleigh scattering to give me that Martian red sky, and voila! I'll have red Skylight to match. Wait, what is my... That's a Martian skylight? That's Earth skylight. It's blue. What are we, Earthlings? Oh, maybe I have to set my sky color using the Skylight sun intensity setting. Yeah, that makes perfect sense. So I'll just grab my sky color here and make it Martian red, and I should get red Skylight. Well, the ocean looks red because it's reflecting the sky color, but nothing else is. Well, don't despair, Martians. SVOGI does in fact provide Skylight, and in any color you like, including Martian red. But strangely enough, it's the old Fog Effects top color that controls the Skylight color and the brightness of the Skylight, even if you have volumetric fog enabled like we do. That old fog is kind of like that zombie that you were sure you killed way back in the woods. Then it just comes back from the dead all like, "Hey man, remember me, man? I'm back. You need me now, don't you? Yeah. You know you do." Yeah, okay, fog zombie, we feel you. But just these 2 settings, color top and color top multiplier. The rest of those settings still do absolutely nothing when volumetric fog is on. So whatever color you set here in the fog settings, SVOGI's Use Time of Day Sky Color controls how much of that color affects the saturation of SVOGI's ambient light. 1 means it uses 100% of the fog top color to saturate the ambient light. If it's set to 0, you get neutral white ambient light. But that doesn't mean you can just thumb your nose at the old zombie fog color like it's dead and gone. because its brightness still has an effect if your sky color multiply value is higher than 0. And you'll definitely want to use that if you're going for naturalistic skylight. Now, if Earth-like realism is your goal, I like to set this to a fairly saturated blue for realistic daytime shadows, because skylight is indeed what fills in shadows here on Earth. But keep in mind that you're throwing that ambient blue skylight everywhere that isn't occluded, just like in life, so you may need to warm up the color of your sun a bit to make sure that your sunny areas don't end up neutral or even blue. Most importantly, you need to balance the intensity of your sky color multiplier to your sun intensity. And just to be 100% clear, as long as you have volumetric fog enabled, and I hope you do, enabling SVOGI does not make the old fog visible. It just uses that top color swatch to set the ambient light color. Alright, and brightness. Stupid zombie fog. By the way, although the SVOGI sky color multiplier and the fog top color multiplier do pretty much the same thing, our own environment artists have told me that they prefer to leave sky color multiplier at 1 and use the fog color top multiplier to control the brightness of the sky. Another subtle but important setting is how saturated your propagated light is, which is set by this setting, surprisingly named saturation. Now you can make your ambient light more saturated than the direct light, which makes absolutely no sense, but is really, really colorful. In general, atmosphere has a desaturating effect on diffuse light, which is why the default value of 0.8 or 80% works well in most cases.
But do as you will, do as you will.
Another component of the lighting system that goes hand in hand with SVOGI is screen space directional occlusion, which is like an improved form of ambient occlusion. You control the intensity of it through this slider, SSAO amount, but there are also a bunch of CVARs that you're going to want to play with to get it looking just right. First, I'm just going to switch off SSDO completely so you can see the difference. R_SSDO 0. Now, right now this factor is pretty subtle, so let's grab our primary tool of destruction, which is the R_SSDO amount ambient level, and just yank that sucker up from the default of 1 to a magnificent 10. Wow! I don't know about you, but I feel a little sick. Now, in truth, if you set this carefully, you can really enhance the three-dimensionality of your meshes. For example, if we look here at the side panel of our old friend Mr. Humvee, even with these really old materials, SSDO really helps out, if you don't overdo it. This setting also helps with subtle contact shadows, like where tree trunks or buildings or whatever meshes actually meet the terrain. And you can see that happening here if I turn SSDO on and off. Now, on video cards whose system spec is set to medium or lower, it might be necessary to set this guy, R_SSDO half res, to 0 in order to maintain performance. You might have to deal with some additional noise that you'll see in grass, for example. In general, the SSDO amount slider works on a scale from 0 to 100% because with SVOGI enabled, you're typically going to want to reduce your SSDO a bit. But as always, test with your own levels until you're happy with it, and don't forget to put your final CVAR values into your autoexec.cfg or your .cry project file so they always load with your game. Okay, before I get into some of the more detailed SVOGI settings, let's look at how meshes interact with the GI system. Now you can actually see the voxels in action if you type E_SVO_debug6 in the console tool. And just a reminder, just type a common sense word like SVO and you'll see all the stuff related to SVOGI, and you'll eventually find what you're looking for. The colors here indicate how detailed the voxelation is, kind of like lotting for light bounces. And you can see very clearly that red, for instance, is the most detailed because it's closest to camera. And you may notice right away that both my Humvee and this reflector that I put here to bounce some sunlight are not getting voxelized. Because by default, this rendering setting on those mesh components, which is GI and usage mode, is disabled. So I'm going to crank up my injection multiplier to a juicy 12, which is like 10, only better, so we can really see the light bounce. And what's a bit confusing is that even with this GI and usage mode disabled, meshes are still affected by the GI system. My reflector mesh is still reflecting, and both the Humvee and the reflector are still receiving both bounce light and ambient light. I'm going to use our old friend R_show_render_target SVO_fin, rolls right off the tongue, doesn't it? So that you can actually see the output of the GI system. And you can see that indeed the bounce light is bouncing and ambient light is also affecting those meshes. But if you look carefully at this scene, with the sunlight coming from the left, it's not quite rendered correctly. There's a weird glow on the opposite side of the reflector from the sun, which makes no sense. The ambient occlusion just isn't what it ought to be. Now this is exaggerated by the fact that I've cranked up my injection multiplier. If I turn it back down to a typical value, it's not so bad. But the point is, we should be able to make this look better. And indeed we can. So the second option for GI in usage mode on mesh components is called static voxelization. I'm going to set that on both the Humvee and this reflector. And because I've made a change to the meshes, I need to force the GI system to re-voxelize the level by unchecking and rechecking this flag, Update Geometry. And after a few seconds, you'll see the change being affected. Now here, I'm just going to cut to the chase and tell you that static voxelization is the recommended setting for mesh components when using SVOGI. It gives you better occlusion and large-scale ambient occlusion, as well as more precise light bounce. It's just the better choice, and the only reason it's probably not the default setting is because, well, SVOGI is also off by default. Now here's a direct A-B comparison that I hope convinces you.
Use static voxelization look.
As far as all these other options for analytical occluders, I don't recommend using them. According to the guy who wrote the GI code, this has never really made it past the experimental stage. You can read all about them in the documentation here, which will also say they're experimental, but as with all things, you can certainly experiment and make up your own mind. One important thing for you to understand, SVOGI performs voxelization in a 70-meter radius around the camera. After that, all you're going to get is large-scale ambient occlusion that's blended with what the voxelation is doing. So when you're evaluating global illumination, keep that in mind. Now, SVOGI also affects how your vegetation looks. Specifically, this setting, translucent brightness, works with the vegetation shader to simulate subsurface scattering, which is one of those magical shader tricks with semi-transparent materials like leaves and skin that make them look the way they do. I suggest that you fiddle with this setting after you have most of your other settings in place. And I also suggest that you look at your leaves and grass in the broader context of your overall scene lighting, both sunny and shadowy areas. Otherwise, it's easy to make happy, glowing, radioactive Chernobyl trees.
Feel the isotopes.
Materials also interact with GI lighting through this parameter that you'll find in the material editor under Advanced Voxel Coverage. This setting controls how transparent the material is specifically to light from the GI system. 0 makes your material completely transparent to GI light, and 1 makes it completely opaque, blocking all the GI light. Another setting that raises a lot of questions is Use Light Probes. Most of the time, we prefer to keep this off, which means that the diffuse light contribution of your environment probes is disabled when you switch SVOGI on. SVOGI completely takes over the diffuse light, and your environment probes just handle specular reflections, which works very nicely. Now, if you enable this, the diffuse contribution of your environment probes gets multiplied with the GI diffuse light. So on one hand, this does give you the ability to place local probes to put some ambient light into specific places, instead of just globally, the way global illumination does. But the bottom line is that the way SVOGI renders ambient light is just a lot more realistic than how environment probes do. Here's a direct comparison between diffuse light via SVOGI and diffuse light via environment probes. While the environment probes give you this kind of telltale flat diffuse light, SVOGI will give you these much more realistic gradients, particularly if you spend some time tweaking the settings we've gone over here. So that's the majority of the significant SVOGI settings. You can use Diffuse Amplifier to control the overall output of both bounce and ambient light, kind of like your master volume control. And don't forget to regenerate your cube maps on your environment probes after you're finished tweaking SVOGI. The last thing I want to go over are some tips to help you troubleshoot and analyze the performance costs of the GI system so you can optimize it. You already know how to use E_SVO_debug6 to see the voxels doing their voxelization thing, and how to set a mesh component's GI and usage mode properties to ensure that it gets voxelized. Now, if you see voxels missing, it's possible that you may just have too much geometry in the current view. Now, this doesn't necessarily mean that you have to redesign your meshes or shrink the number of polys, but you may have to just remove some meshes to make your scene less dense. Try hiding some of your meshes and see if the problem goes away. This is exactly the process we went through on Hunt Showdown, where we ended up reducing the amount of vegetation in areas where we also had a lot of buildings and props and etc. In terms of performance optimization, R_Profiler1 will give you a pretty terse summary of the cost of things like shadows, GI, fog, etc. R_Profiler2 will give you a much more detailed breakdown that helps you figure out what each element in the rendering pipeline is costing you, and make adjustments to improve performance. For example, you can see that the SVOGI system as a whole is costing me several milliseconds on the GPU. HDR is costing me a surprising number of milliseconds, etc. And that, ladies and gentlemen, is all I have to say about global illumination for this tutorial. I hope you found it useful and illuminating. Go forth and make magic.